Hello guys, Code Analyzer here, and today we are going to solve the problem A, B, C of contest 1369. The first question is pretty simple. I'm going to quickly explain it. I won't implement it. It's really easy. So I think you should be able to implement it on your own. So I'll switch to pen and paper now. Hope you'll understand it. So according to the question, we are given a number ni and we have to tell whether the polygon having ni sides is beautiful or not. So if you just observe by drawing 3-4 polygons, you'll see, let us make this axis, then you see triangle has only one side. You draw a square, it will have two sides. Now similarly, if you draw a pentagon, so it won't have two sides, like these are slightly like this. So this is more accurate of a pentagon. So, and then you have 6, 7 and so on. So you'll notice that only if a number ni is divisible by 4, then it has this sides parallel to both of the axes. So it is pretty simple to implement. You just have to take the input C in ni and you have to check if ni percentage 4 equal to 0, then print yes, else no. That's it. So we'll jump to the part B now. So let's jump to the question B, and I'm showing this question just so you can refer to it. I'm going to explain it on pen and paper. So if you want to read, you can just pause the video and read it. So hope you have read the question now, and I'll try to explain the question. So the question says we are given a string S and it is a binary string, that is the elements are 0 and 1. So the operation that we are asked to do is we are asked to clean it. Suppose we have one string that is given in the example, which is 0 0 0 1 1 1 1 1. So in this string we can clean only if there is a 0 after 1. So say we have this string 1 0 1 0, then we have this 0 after 1. So out of these two we can erase any one of these 1 or 0. So next output from this operation we can get either 101 or 100. Then now our motive is to make a string as small as possible. We have to reduce the size. So s dot size, we have to minimize it. Now, and we also want lexicographically smaller. So wherever we have an ambiguity of choosing 1 or 0 at smaller place, we should try to choose 0 so that we get lexicographically smaller string. So for that, the idea is we are going to take any string. Let us first consider this string like 1 0. So in this string what we can do is we can remove any one of these two. So if we remove 0, then we'll get 1, otherwise we'll get 0. So this is 1 is better clearly lexicographically, so we get this answer. Now if we do this 1 1 0 0, what we can do is we can get here, then we can get here, then we can get here. So it will also reduce to 0. Now what I want you to notice is that anything, if we have 1 in the beginning and 0 in the ending, then whatever is there in between will vanish. So suppose I have this 1 1 1 1 0 0 0 0, then these two you can make 0, then it became 0. Now you can make this 0, you can make this 0. Now this 0 and this will become 0. Now you will get 1 0 0 0 0. Out of these you make 1 0 0. Now you make 1 0 0. Now you make 1 0, and out of this you make 0. So definitely you are going to reach 0 if you have anything that is sort of big ones in the beginning and zeros in the end. Now let us take it one step ahead, like one step further. If you have 1 in the start and 0 in the beginning, then doesn't matter if you have continuous ones or not, you will definitely go to 0. How? Let us just see this case, like 1 1 0 1 1 0 1 0 1. Now in this case 1 0 will become 0. These wherever you can get, just make it 0 first. So definitely you'll be able to make 0 here. Now you make 0 here. Out of these two you make 0, so you get 1 1 0 0 0 0 0. Out of these two, now you make it 0. So you'll see that all these type of cases will convert to the cases that we have already seen, that is ones in the beginning and zeros in the end. So we can easily convert them into this and then this into 0. So we can say that whenever we have 1 in the beginning and 0 in the end, we can convert this whole array to 0. Now what we can do is, suppose we have any string now which has zeros in the beginning and ones in the end. So our motive should be, let there be anything in the middle. We have, say, k characters, k numbers, zeros or ones, and we don't know what they are. They can be 0 or 1. So if we find the first one from the beginning, so we search for 1. Is this one? No. Is this one? No. Is this one? No. So wherever we get 1 and wherever we get 0 from the end, so this substring is a case which we can reduce to 0, right? So we'll replace this with 0. So 0 0 0 1 1 1 1. Now you should also notice that if you have zeros in the beginning and ones in the end, you can't reduce it further. So this will be the answer for our such cases. So the whole question has now reduced to finding the first one and last 0 in the string. The whole question is now reduced to finding the first one and last 0 in the series. So what you do is you find the first one and last 0, replace everything between them with a 0 and produce the output. So you have S1, 1, S2, 0, S3. So what I'm saying is you can replace 1, S2, 0 with a simple 0. So answer will be S0, S3. Now we'll try to implement this. So this is inside the loop, and this is for every test case, and we are going to take the input now. So for every test case, we are given one n and then the string. So n is the size of the string. If you are new, I'll suggest that you have a look at this function fast and try to learn from internet how it works and what it is, and you should also implement this in your codes. Okay, so C in S. Now we are going to find the first 1 and the last 0. So I is already 0. I'll start like this. While Si is 0, I should increase I. Right. But we should also check that while increasing I, the next I should not be greater than n. Otherwise, we'll get an error. So if I plus 1 is less than n, then only do this. Else, we can just end the loop because I has become greater than n. Okay, fine. So we have found the first one. Now we are going to find the last 0. So for that, we are going to start iterating from the end of the loop. So before that, we should check that I is not equal to minus minus 1. So if I is not equal to n minus 1, then only we need to do that. Otherwise, if I is equal to n minus 1, that means that the whole array is simply containing only zeros. So we don't need to check anymore. We can't reduce the size. Therefore, if I not equal to n minus 1, then we should start iterating. So I'll iterate with the help of j, and I'll start from n minus 1. So while Sj is equal to 1, I'm going to continue, and similarly I'm going to check if I plus 1 is greater than equal to 0. Sorry, I minus j minus 1 it is. Then j minus minus, otherwise just break. Okay, we have found this. Now we simply need to erase it from the string. To do that, we can simply use the inbuilt function, which is s dot erase, and in this function the first parameter is the index at which we want to delete it. So that will be I, and the number of elements that we want to delete, and that is simply j minus I. Okay, so now we can print our array. It's done. Okay, so this doesn't give an error because I have a macro defined like that. So there's one more catch. You should also check that j minus I is not less than 0, because if that is the case, it will throw us some errors, and we don't want that. Also, in that case, we don't need to erase anything. I'm sure you can work it out if you think of it. So it's done now. Let's try to submit it. So yes, it is accepted. Hope you have read the question, and I suggest if you feel confused, you should refer to the question again and then see the video. So according to the question, we have n gifts. So Mr. Lee has n gifts, and the ith gift is AI. The ith member is of the A array. Now we have k friends, and each friend has a capacity. So Wi. Ith friend has capacity Wi. So what we are told is that we have to distribute these gifts to the friends such that the minimum and maximum gift for each friend, the sum of the minimum and maximum gift is maximum. So let us try to understand this with an example. So for the first case that we are given, we have n equal to 4 and k equal to 2, and the gifts are 1, 13, 7, 17. So this is A array, and this is W array is 1 and 3. So one person will get 3 gifts and one person will get 1 gift. So if we give 17 to the one, then we'll get 17 for the first person, and for the second person we'll get 13 and 7. Now what we want to maximize is this. We want each person should have maximum possible min plus max. So min plus max for this will be 17 plus 17, and for this it will be 13 plus 7. So the minimum element of this array plus the maximum element of this array should be maximum for each person, and then we have to print the sum of these maximum, minimum and plus maximum sums. So the idea behind this is we'll use sorting. So say let us consider this example: 10, 10, 10, 11, 11. This is already sorted. Now we have 3, 3. So this is a simpler case. This is our first person who has 3 capacity, and this is the other person which has 3 capacity. So we should think in this way that we have to first maximize the maximum number. So the maximum number should be maximum. So if I give 11 to here, then I should give this 11 here, because otherwise its maximum will be any of these 3, 10, which is definitely smaller than 11. So we want to give the second 11 here. Now we'll give next 10 here, this here, and this here. So our sum will in this way become maximum. Okay, there was one more 10. So yes. Now this is a simpler case. Now we have not noticed those corner cases that will come into play when we are submitting a general solution. So the case is n equal to 4 and k equal to 2. For this case, n is 1, 13, 7, 17 and 1 and 3. So one capacity is 1, other is 3. So if we want to maximize, then we should give the maximum number to, we should maximize the maximum number of each person. So if I give 17 here and 7 here, then the maximum for this will be 17, and minimum we have to still fill. But the maximum for this will become 7, and minimum will also become 7. So the sum will become 14. So, but if we give this 17 here, then we'll get 17 plus 17, which is 34. So which can be better, you know. So it is definitely greater than 14, and then we can get something else here. So what we should do is, we should try to fill the smaller one first. So we'll fill the maximum number of each person first, and then we'll try to fill the smaller person first. So for that, we have to sort this 1, 7, 13, 17, and then this 1, 3. Now draw the capacities and fill the maximum first to the smaller. So smaller is this one. So 17 goes here, then maximum goes here, 13. Now start filling from the smaller ones. So here the smaller is filled. full, so I'll give 7 here, 1 here, and in this case, in this way we'll get our answer. To completely understand, we should look at one more case before implementing. So where we have something in middle like 2 or something, so I just consider this case. So we have 1 2 3 4 5 6 7 8. These are our ai, n equal to 8 and k equal to say 3. So k equal to 3, we have 2 3 3. So I've chosen this. I've already sorted both of these strings. Now what we'll do is, according to our algo, we'll first give this to the give the maximum numbers to each one of them, starting with the smaller. So give 8 to the smaller, then 7 to the next smaller, 6 to the next smaller. Now we should start filling other numbers, starting with the smallest. So 5 goes here, 4 goes here, and fill it till it is completely filled. 2 goes here, and 1 also goes here. So 2 1. This way, the maximum plus minimum from this is 7, from this is 10, and from this is 13, and this sum will be maximum. It is 30. So that's the algorithm that will work for this question, and now we are going to implement it. We are given first n and k, then values of ai, then values of wi. So in each test case, I'm going to take input of n and k, and then I have two vectors. Vi is vector int, and then we have two vectors a and w. Now I'll also create one vector of vector, that is array of vectors of size k, to store the number of to store just the gifts that each person is receiving. Okay, so back itr is just a loop. I need to tell the name and then it works. It gives me an iterator. So cin it, and similarly for w I need to do. Okay, fine. So if I just provide the size, it will work. Fine. Okay. So now we'll first start giving the maximum numbers to each of them. Okay. So before that, we'll sort both of them. We'll sort a from beginning to end. And then we'll start giving the first ones. So okay, I'll start from the last. I'll take one variable which points to the current number in the a array. So that is j. We'll start from n minus 1, the biggest number, and we'll give it to the first one. So g of I will push back the jth number in a, and then we'll add it to our result, that is the answer, because it is maximum of one of the arrays. So we'll add it to the final sum, and that is a j. We will decrease j also. All done. We have given all the maximum numbers to each one of them. Now we are going to fill the rest of these numbers. So once again, we're going to iterate over all of them, and then while g I dot size is less than w of I, we are going to continue adding the numbers, and before that we are going to store the number which is already present at 0th position in m. So g I 0, and then we'll use it to find the maximum number. So basically every time we are adding, we'll compare m with the number we have added, and we'll store the maximum number. So let us add the next number. Okay, g I dot pb is pushed back, if you might have noticed that. Okay, so a j, and m equal to maximum of m and a j and then j minus minus. Okay, fine. Now after all of this, we are going to add m to rest. So this will also work for the case when only one number is needed to be filled in the gi. So basically when wi is 1, this gi dot size will already be 1, so we'll store maximum minimum number in this. Okay, I found one mistake, which was minimum, so we'll store the minimum in this. And even if gi dot size is 1, we already have the minimum, and then we are going to add here. Now we can print res, and that should work. Okay, so it worked on the given cases. It shows the same output. Now I'll try to submit it quickly. Yeah, it got accepted. So thank you for watching the video. If you liked it, please hit the like button and subscribe. And also, if you have any doubt, you can ask it in the comments. I'll definitely help. Thank you.